The excess internal energy of metabolism is exhausted through a variety of channels, such as through radiations and evaporations of perspirations. Consider another pathway for energy loss: moisture in exhaled breath. Suppose you breathe out 22.0 breaths per minute, each with a volume of 0.600 liter. Suppose also that you inhale dry air and exhale air at 37 degrees C, containing water vapor with a vapor pressure of 3.20 kilopascal. The vapor comes from the evaporations of liquid water in your body. Models the water vapor as an ideal gas. Assume its latent heat of evaporation at 37 degrees C is the same as its heat of vaporizations at 100 degrees C. Calculate the rate at which you lose energy by exhaling humid air. The liquid in our bodies, through the evaporations, it will become the water vapor. Now, if we can treat this water vapor as the ideal gas. So that means through these evaporations, some of the heat from the bodies would be contained in the water vapor. Now, if we exhale air, exhale the water vapors, that means the heat that contains in the water vapor would be carried away from our body. So that means it will cause us the heat loss of our body. It is given in the questions that in every breath, the volumes of the water vapor produced due to the evaporations of the liquid in the bodies is 0.600 liter. Since the evaporations happens at 37 degrees C, we can take the temperatures of the water vapor produced as 37 degrees C. And as mentioned before, now we assume that this water vapor is an ideal gas. And the pressures of the water vapor, or the vapor pressure, is given as 3.20 kilopascal. So from this information given, that means we know what is a V, what is a T, what is a P. Therefore, we can calculate the number of mole of the ideal gas. Okay, we treat this water vapor as the ideal gas. We can calculate based on this V, P, and T. We can calculate what is the number of mole of the ideal gas produced in every breath. And if we know the N, based on this ideal gas law, we calculated the N, we can a number of mole, then we can find out what is the mass of the water vapors that produce. Now, if we know what is the M, based on this Q equal to MLV, we can calculate what are the heat loss by the bodies from the bodies by using Q equal to MLV. Remember that we did mention just now that heat loss, actually the heat, where is the heat come from? Actually, it's come from the evaporations. The liquid in the bodies becomes water vapor. It needs the heat to become the water vapor. So this heat is contained in the water vapor, and now this water vapor is removed from the bodies through the exhalings of the air. Okay, so we can calculate what is the total heat removed from our bodies in every breath. But in 1 minute, we know that there are 22.0 breaths. So that means once we know the Q, then we can calculate what is the total numbers, not total numbers, sorry, the total heat, which is total heat loss by the bodies through exhaling the air in every minute. Now, before we start to solve the problems, we convert first the V given in liter into meter cube. Now we multiply with 10 to the power of -3 meter cube, because 1 liter is equal to 10 to the power of -3 meter cube. And the temperature of the bodies, which is 37 degrees C, also the temperature at which the evaporations taking place, it is 37.0 degrees C. Converted into Kelvin, it is 310.15 Kelvin. Now, by using the PV equal nRT, we can calculate what is the number of mole of the water vapor produced in every breath. So N equal to PV over RT, where the P is 3.20 kilopascal. The V, we take these values, and the T is 310.15 Kelvin. R is a gas constant. So we will get N equal to 7.4 times 10 to the power of -4 mole. This is the number of mole of the ideal gas, which is in every breath. In terms of the mass of the water vapor produced in every breath is 1.34 times 10 to the power of -5 kg. This value can be obtained by taking the number of mole here multiply with the molar mass of the water, because which is H2O. Then the molar mass of this water is 18 gram. In kg, it is 18.0 times 10 to the power of -3 kg. So we have this value for the mass of this water vapor produced in every breath. Remember that this water vapor is produced through the evaporations of this liquid in our body, and it is mentioned in the questions that the evaporation happened at 37 degrees C, and the latent heat of evaporations happen at 37 degrees C is the same as the heat of vaporization at 100 degrees C. So that means this LV, this value of LV, we can take 2.26 times 10 to the power of 6 joule per kg, because this is the value of the specific latent heats of vaporizations at 100 degrees C. Okay, so this M is come from this value. Then we'll have the Q is 30.3 joule. This is the heat removed from our bodies, or the heat loss of our bodies through exhaling air in every breath. But in 1 second, we breathe out how many breaths? It is given that we breathe out 22 breaths per minute. So that means in 1 second, it is 22 divided by 60. This is the numbers of breath in 1 second. So if we take this value to multiply with 30.3, which is the energy loss in every breath, then we'll get the P, which is 11.1 watt, which is the energy loss in every second when we breathe out the air. Okay, so this is the answer. It's a heat loss from our bodies when we breathe out the air in every second.